Hi, my name is Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this Sunday, the 11th of May, 2025, where we will be discussing O-Day Inside Out. Matter, energy, matter, energy, matter, energy transducer. We can begin now because we have Rotus Chris there in Australia is in the house. And we also have, obviously, the ever-present and ever-sleep-deprived Gordon Doherty, and John Coombs, DIY Projects with Chowks, is also in Australia. Hi, John Coombs, Bo Sinclair, Tammy, Power and Prep. Hi, Mika Avila. Hi, Freedom Now and JK Philly Fan. Ken Pratt, Artifact, Nathaniel Hanks. Good to have you here with us. And Earthworm Jim, it's good to have you here on the live stream. Matthew Reynolds, William Schwent. Yes, Hyman Spirell, EBB. We have got some representation from Canada, Europe, Australasia, and Merlin's Boy. Wonderful to have you join us. Okay, so I've had a week of failure. I still haven't fixed my camera. That's why I've got this wonky camera that may or may not be in phase with my speaking. So you'll have to let me know whether it's really terrible to watch. But I don't think it's going to be great. Hi, Kimo Vartiri and Craig Miller Piano, Miguel O.C. So, and Snow Buddy, Athena Mac, Joseph Collar, Overwhelmed Games, Vanilla Isis. It's a wonderful, what a great quorum we have. Okay, so yes, this is the camera we're going to have to put up with today. I lost my microwave oven and grill and my washing machine, and the car gave up as well. So it's not been a good week. But on the plus side, my gout has gone. Okay, so inside out. Well, what we have here on the screen is a little AI-assisted imagery that I produced. And I'm going to have someone say, can I have a bigger mouse pointer here? So I'm going to fix that right now because someone actually asked for a bigger mouse pointer. And actually what I'm going to present to you today is a kind of subset of what I want to do in my poster session in ICCF 26 in Japan, which is coming up quite soon. They're in Morioka, in Honshu. And I actually did a longer form presentation than the short form presentation I am going to do for you now, because I'm hoping and assuming that quite a few are people that have followed my work for a while, so I won't have to go over all the old ground. Although I did record what was said in the presentation a few hours ago, and that I intend to publish, and there will be a premiere of that maybe tomorrow. And so that will be more long form. So for those of you that are new here and you don't know what I'm going to be going on about in some of the words that I'm going to be saying, it might be the case that you will find solace in the longer form. And if that's not enough, you'll have to delve into the material that I've shared over the many years. Okay, so I'm just going to go to the system settings here and make a bigger mouse. And hopefully it'll still click in the right place. We'll see that. If that's the case, mouse. So, whilst I'm doing that, I would like you to guess what I am going to talk about in Inside Out. If those of you who have read my blog at remoteview.icu, you might have a clue. Think amongst yourselves and see what you're going to say here. Right. Have we got the scale of my mouse? Mouse zooming? No. It's probably in... It's probably in accessibility options, isn't it? Under mouse, accessibility. Anyone know how to scale my mouse? I don't want to dwell on this. Advanced, no. All right, I'm going to leave that there because I don't want to dwell on it too long. Okay, so you may recall that in my blog post, I can't eat that for breakfast, Bob, says DIY Projects with Chowks. I don't think anyone can eat it. I kind of imagined it would be a kind of pumpkin soup, and someone's thrown in there the remainder of the wasteland of unloved food coloring in the US now. Okay, so hi Venom K. Has anyone got any ideas about what I'm going to talk about today? Anyone got any ideas? Okay. Well, I think we'll have a couple of slides to kind of like set the stage, and these are the sides that were really transformational in my personal journey. For those of you that have been along that journey, you will know and have seen these slides before, I should imagine. And I think probably one of the most important slides was this one from the Lion reactor. Actually, to do this in order, we actually have to start with the hydrodynamics of Suhasralkar. So we will do that. Yes. Hydrodynamics. So, this doesn't quite go into plan. Okay, we'll go over here. I've got it in here. Okay, yes. All righty. So this was in 2017. And it was in Suhasralkar's lab in Mumbai. And there was this chamber. And in that chamber, there was a aluminium cylinder. And that aluminum cylinder had transducers, 19.46 kilohertz on the top, producing intense pulses of ultrasound. It's kind of technically in the sound that you can hear, but most people can't hear 19.46 kilohertz. And it produced a range of structures within the water. And some of them were ring solitons, like you can see over on the right here. And they broke up into their own large wave functions, but also in regular spacing around. Under later analysis, it was found that there were these helical waves coming in at regular spaces around the edge on this right-hand side here. So this is hydrodynamics. And here we have also hydrodynamics in a smoke ring, another smoke ring here by alien scientist, and a laser cutting through that. And over on the right here is some close-ups, this particular one of the water and nanobubbles that were being seen in the ultrasound device of Suhasralkar. And this lower structure is incredibly important to my journey because I couldn't understand how in this lower structure on the bottom right here, there was depressurization in this whole area here. How was that possible? Moreover, there were these two beams that came down and pointed to somewhere over here, and kind of like below that, there was depressurization that would suck bubble packets into this overall structure. But if there was depressurization all the way around in this kind of like cloverleaf shape, where was the pressure going to? Was it disappearing? How was that even possible? And so that mystery, along with a very different type of system by one Neil Crichton Gold, sadly departed, where I saw these very particular structures on his Lion reactor outside core. So one is hydrodynamics. This one is magnetohydrodynamics, but I didn't fully understand it at the time that I was seeing this. And we actually, live on video, broke this reactor structure up and found this particular structure. Again, you have a vortex and then a counter vortex. You can see the flow patterns coming in this way, and this one is larger and this one is smaller. This one is underneath this structure here. And it turns out that the flux is coming from this one, went over, and this bend in the heater wire was centered here when I opened the reactor, and you can see live on the video. And then it had this geometric pentagonal, maybe hexagonal structure on the top, but there was nothing on the bottom, okay, just on the top. And when we looked at this top structure, there was calcium bearing compounds which did not exist in the silicon dioxide, the air, or the alumina that was in the near proximity of this structure. Anyway, this was a magnetohydrodynamic structure, and looking at other parts of the reactor, we found another type of magnetohydrodynamic structure here, which again had one side overlaying another. On the back side, you could see these were hexagonal in shape, and it had these vortical spirals around a central vortical spiral. And on the back side, you could see a flux loop going between the two sides. Anyway, another piece of data that's showing what's going on in the hydrodynamic space was by a separate author, and it was done in Germany. And this is the slide, and it was rings of streaming bubbles at 25 kilohertz. So I was working at 43 kilohertz in our research. In Suhas Ralkar's, he was 19.46. This work was done at 25 kilohertz. But what it shows in these two images was very important to my overall understanding, because we had bubble streams being manifested coming into a dead stop here, both from a ring apparently coming from over here, and also from the far field. So it looked like there might have been two structures in here that were kind of orbiting or whatever, or that somehow this was linking to this structure, which is self-similar to this one. And the way I look at this is there's a depressurization up to this point, and then there is highly pressured matter that's shot out of here, but you can't see it. But partially it's pulled into this depressurization ring, which also is pulling in new material from here. On the more fractal level, you have two arms of like a spiral galaxy here, two arms of a spiral galaxy here, and that also has a kind of pull in and a pull in, but there's this helical beam coming down here, and there's this helical beam coming out here. So is this the pull in side, and this is the helical beam coming in? This is the pull in side, and this is the helical beam coming out here. I don't know, but there's a kind of a mirror of it over here with a self-similar type of thing going on. Anyway, just drawing on this left-hand side, we look at the basic magnetohydrodynamic structure in 3D. And what I'm arguing is that this bit and this bit are this bit and this bit respectively. You just kind of need to rotate this in your head so that this flow line and this flow line are coming into this point here. And you get two helical beams because you have a self-similar structure at the next quantization level down. And this is just a manifestation of, in 3D, of the 2D structure that I'm showing here. And if we zoom into this level, we can see the fine structure of this. Okay. So what we're looking at is a tornado that is pulling stuff in, and into each fractal level. That was 2017. Two different examples. Suhas Ralkar in the cavitation bubbles, and also late Neil Crichton Gold in his nickel, diamond, and deuterium reactor. The image that really shocked me, and it was a difficult thing to deal with at the time, and I paced around Alan Goldwater's lab there in 2019, waiting for Alan to get up, and Alan got up, and I said, and I had to kind of like, I paced around in the room in his lab, and I said, Alan, when people understand the significance of this particular image that I'm going to show you, it's going to melt their brains. It's going to melt their brains. And what am I referring to? I am referring to the image of where we took a Mars gas and we used that Mars gas on a tungsten welding rod. And I'm going to find it. It's coming. Somewhere here. I've got it. Okay, we'll do it in here. So in the, it's going to show me here. In the line reactor on the left, we have a structure which gave me this kind of basic toroid structure. And this showed that at 1050 degrees, copper oxides, which are not molten at 1050 degrees at all, can be fluidized in such a sense that they can be swept in a torsional fashion. Also, that there is a hole with no material in it, and then there is a lopsided structure, which implies, in my view, an overall structure that was something like this. But it was the thing on the right that shocked me the most. This was both, this was in 2017, but this was in 2019. We had shown that a Mars gas on tungsten was not vaporizing it as was thought. In fact, the temperature on the bolometer on the PI Optris PI 160 wasn't even at the temperature at which tungsten oxidizes. And it actually, we didn't get the tungsten oxide on there, the typical crystals that are yellow. It was at a much lower temperature. But this kind of white fuming thing was coming off. And this was Amaza's belief that it was vaporizing. So the temperature must have been around about 3,600. He was very disappointed when it clearly was not anything like that temperature. And George Eagley was holding a vacuum cleaner with the nozzle covered over with a face mask. And my idea was to capture these particles and then see what was on the transmuted material on the tungsten and in the particles in the caught in the fibers of the face mask back in 2019. It turns out that in both places there was all of the elements you typically find in your body, a lot of calcium, and calcium in every spot that we saw on this structure here. Had calcium in every part and in all the substructures that we saw in addition to this. Now that's one thing, but here there was a strontium sphere and there was film of carbon with this wavy line. And when you look at this in context of all of the other kind of structures that get formed, here is our original hydrodynamic vortex with our depressurization here. And it's twisting round. Here is aluminium and it's got a twist this way. this has got a spiral coming into it. It's twisting. It's lopsided. But here you can see the hydrodynamic vortex, which is magnetohydrodynamic. And what I saw here, and when you know that this area here is a carbon film, where the hell is the carbon coming from when it's only in part of this vortex, which we already know is a depressurization. A depressurization of what? And a depressurization how? Well, you can imagine a depressurization of water, although it's fairly incompressible, but certainly a low pressure or a pressure gradient, something being pulled along, allows the bubbles to come out of being compressed by the rest of the water pressure. But down here, what on Earth is allowing this matter to be decompressed? And how is it producing a carbon plume on one side because it's spinning over, it's spinning over, it's spinning over. So something is coming around this way, but an overall depressurization is coming up here. How is that occurring? Well, it was later that we observed more tornadic structures, which gave us more clues as to what was going on. And I think for me, the favorite image of all of those was probably this one that I shared many times, but it was from Henk Uren's Vega Valley experiment here. And I've overlaid the sacred geometry and a n-1 Tor sacred geometry basic hydrodynamic vortex structure, which has flown out of this side. And here we have the tornado structure coming into the core. Where this central part was here, it was where this iron-rich crenellated sphere was with its hole, and the hole has the material spewing out of it. And what we find in these systems is, and you can see it here on the subtor, is that the material is pushed in, and when the system dies, it comes out. And we saw this absolutely conclusively in many examples of that we observed on Binzhuan Huang's system. And if I can find the right imagery here, do I want that one? This might do it. No, I want... just bear with me. I'm going to get the ICCF, not the ICCF, the Strasbourg presentation. Give me a second. If I can find it. Okay, so this was my ICMNS presentation here. Extraordinary repeatable evidence in multiple plasma and cavitation systems producing anomalous effects. And the key slides, I think, here, for me, in this aspect, are things like this, where one of these cores is spewing out carbon. Here you can see carbon by atomic ratio 85% roughly, and then oxygen, and then a bit of sulfur, sulfur being the fusion of two oxygens, and then copper is probably copper seen from underneath. Maybe even oxygen is seen from underneath. So it might be mostly carbon and oxygen. Okay? But at the end, you see these two tori that are being spat out, and they are also containing aluminium here and titanium. Aluminium is kind of like the fusion of carbon and oxygen and producing aluminium and hydrogen, and titanium is the fusion of CO2. So out of this area here, material has been ejected. And we saw the same thing in Bingjuen Huang's reactor. We actually saw a broken core where there was material inside. And we also saw another broken core here where there were tori that had mixed elements in them, fairly evenly spaced. This is the iron core boundary on the outside, which is broken. And we have all of these tori in here with substructures. And what they were, you can see here, carbon and oxygen predominantly. Same thing we saw spewed out of an iron-rich crenellated sphere that kept its integrity. And then down here you see the same thing, aluminium, a little bit of silicon, and silicon is just the fusion of carbon and oxygen, and also titanium. So two different systems. This is a cavitation system, and this is a plasma system. But out of an iron-rich crenellated sphere, mostly carbon and oxygen with some titanium and aluminium, and out of a cavitation system, when you analyze the structure inside, I didn't have the analysis on, it was broken on that SEM that day, so I couldn't analyze inside here that day. But in another session, we found a whole broken sphere, and the inside contents were matched the plasma system. Now, what we found in this work, was that matter would spew out of these magnetohydrodynamic structures that were observed in the Bingjuen Huang reactors. So here is an example of two of those. This is a yin overall vortex structure with a yin and a yang, and this is a yang with a yang and a yin vortex that way, counter vortex. Exactly predicted by work that was being done on nanometric ferroelectric nanotori in Physical Review B in 2014, but for storing memory. A vortex one way and a counter vortex. Okay, I predicted I would see this in systems, and it was actually in a presentation talking about ultrasound driven cavitation processes to produce LENR, and ultimately that's what we saw it in. Now inside one of these structures, the wheels that are substructures to this spew out. Okay, and just to confirm that, you can see down here in this lower set of imagery here that one of these so-called apples, these apple-shaped structures, has buried itself 50% in on its side, and it is exactly the shape of the apple of the magnetohydrodynamic structure. Exactly the shape of the apple of the magnetohydrodynamic structure. Without changing the scale or this image, so it's still 20 microns across, and without changing the actual scale of this image, I go to another area, and the substructures in here are exactly and correctly the diameter of the inner n-1 tors as they are arranged in the structure as it collapses. Now, again, up here, this one's embedded on its side, this is embedded on its side, this is starting to fold over, this one's actually disappeared. If you go and look at it, it lines up with the actual tori, the actual torus core, okay, except for the bit that was here has gone away. And this one is in 50% the other way. But look, something is spewing out of it, and this is predominantly carbon, okay? Now, on a larger fractal level, we can see, do I have it in this presentation? I don't have it in this presentation, but we can see that the material, I think I need to go to the right presentation for this. What are we on? I'll go to Tesla Tech. I think I got it in there. Yeah. Yeah, okay. So when I'm showing you this one, here, I'm showing you these stable structures coming out of here. And what this shows us conclusively, in my view, and thank you to Binjuan Huang, from his DHX2 reactor, is that this can die, but this is stable and comes out, and it's still spinning. And the next set of slides, I show a structure where the overall apple has crashed in here and it's gone away. But, as I said, out of the place in which the matter comes in, so this is the point of destruction here, matter is depressurized and gets pulled into here. And when the overall structure fails, this breaks off. It comes out of the way that it comes in. And so the two substructures here were here. And then this one died, and the two substructures in there, the N-2 structures, came out. This therefore shows that the N-2 wheels that are within this wheel, which was in this wheel, the N-2 structures are more stable than this, and these are more stable than this. This is absolutely critical to understanding what I'm going to show you, or what I'm going to walk you through. Absolutely critical. Okay? But that wasn't the only thing that we saw in these systems. I'm going to have to switch to the other presentation again. What we saw is, from these apples, very regularly, large amounts of material spewing out of them. Right? So we know this has died, it's crashed into the copper oxide, it's a different makeup to the copper oxide, and out of some area it is breached and material from in there has come out. And you can see it's like a braided helical structure. In this one it died, and it's very difficult to imagine all of this carbon and other elements have come from the volume inside here. It's very different to imagine this. How on earth did all of that fit in here? In this case, it completely broke up and disheveled monstrously, with even its subcomponents dying. But we have a braided structure here, a braided structure, and it has heavier elements in here. So this would largely be carbon and oxygen, and typically these bits are the fusion of carbon and oxygen, which is titanium. You might find some silicon in here as well. So there's a range of elements being born in this process. In this one, you can see it has a tornadic slug being pulled into the toroidal moment, the vortex. In this one, it has a bit of copper that's been spewing out of the side. In this one, you can see where the apple had its tornado reaching down and making touchdown at this point, and it caused some material to be dislodged. Just like a tornado will lift up material, a whirlwind will lift up material. But as it was lifting up material, it was also pulling itself into the substrate. And so ultimately you got a channel that widens out, and then the apple structure collapses and embeds itself into the copper oxide. Okay? Now this is a structure that's died, and the actual material, which are stellar synthesis type material, is spewing out of this little hole here in a tornadic flow. So the spinning that was going on inside the substructures in here emerges out in a similar fashion. And we shared many such examples. So what is actually going on? what is actually going on. Well, showing this slide, you can see the ball lightning here. And if we look through that ball lightning by changing the optical parameters, sorry, I'll try that again. We can see through to see the tornado soliton, the torus here, and the tornado coming into the torus. And that torus extends out through to the outside of the reactor where it touches down, and where it touches down, it's pulling something through the iron, which excites it almost instantly into an orange state. And I believe this is overexciting the atoms. And this, in my view, is absolutely critical to what I shared and what I believe was going on in my ICCF 25 presentation, which I'm now going to find, which is here. And it was called Practical Applications of the Fractal Toroidal Moment. So there was someone that asked, will you be telling us about any practical applications? Well, the entire presentation at ICCF 25 was focused on practical applications of this technology. Things that people didn't even realize was using this technology that already exist and you can buy, that have been used in some cases since the 1920s, like wire electrode discharge machining. But it's a bunch of slides I gave here, starting with this one, if it actually lets me go to the slide I want rather than the start, because I pressed the wrong button. Okay. Effect of fractal toroidal moment on matter. And over here you can see the same outside that I just showed you, and the tornado touchdown making this little yellow spot move around as the tornado is moving around on the inside of this reactor. And having seen this, I asked Henk to put some different materials inside this tube and see what happens. And I need to spend some more time sharing the data with you. But for instance, we put a brass, or rather he put a brass screw in here, and it turned into like a sponge. So in different areas of the brass screw, it was sucking out the nuclei, but leaving part of the shell of the structure there. Changes in all forms of electron interactions. Overexcitement of condensed matter nuclei resulting in anomalous glowing transmutation over time. Non-thermal plasticity and material flow. Critical fragmentation. Production, capture and coherence of matter waves, and collapse of matter waves into different configurations. But it's what it does to electron interactions which is critical. Casimir forces, that is to say, modification of the electromagnetic vacuum fluctuations by the presence of boundaries such as conducting plates or dielectric materials. So this is what the Casimir forces is, but this causes a change in the Casimir forces. Van der Waals forces, polar bonding. So it causes water to fall apart without the water boiling. I believe that this is why you get water lifted in a water spout, and it's also why you seem to get efficient production of so-called steam, more than you would ordinarily imagine from cavitation type devices. Ionic bonding, covalent bonding, and metallic, including between crystal grains, etc. But it goes further than that. It goes much, much further. I'm going to give you some broad brushstrokes here. But essentially, if you go to the original ideas of John Archibald Wheeler, he says that you can make a thing that he called a Kugelblitz, which he said is a pure electromagnetic, trapped electromagnetic energy forming a black hole. It's interesting that he used the term Kugelblitz because that is the German term or German name for ball lightning. Now, I'm not going to go into the maths, but I will show the maths in my paper for ICCF 26 to justify what I'm about to say to you. I will show you the maths, or it will be in the paper for ICCF 26. Yeah, I need to go here. Where is it? Okay. In our journey together, and it has been our journey together, my thing has messed up here. I don't know why that happened. I'm having a lot of technical issues this week. I shared these images here. The original structure, the wheel within wheel within wheel structure that I derived from study of John Hutchison fracture sample, the collapsed wave functions from plasmoids in or plasma toroids, as they should be correctly called in my view, in Hent-Uren's Vega experiment. And I sent those to the Russians, and they came back with this paper called The Bagel Game, which described exactly the same, with diagrams, the way that I saw this structure being formed that caused the footprints on the John Hutchison sample, which is current loop forms a magnetic field through the azimuth. You rotate that through 90 degrees, you get, they're showing 6 here. That produces an electric field. It doesn't actually, it produces a toroidal moment. But anyway, you take that and you produce 6 of these 6 rings around here. And this is producing actually a second order toroidal moment. And what happens in this case, when you've got it as a wheel within a wheel within a wheel, you have a phase singularity at the center of the structure. And this phase singularity is also observed in this work in Physics of Plasmas, published in 2021. It's a replication of 1973 work done in Japan. You fire a laser into a nonlinear plasma. This is just a single laser pulse, and you get a magnetic ring of 1.36 thousand Tesla and a magnetic section in the middle that stops dead at the phase singularity. Okay, and over here you can see the flow of the plasma, and it is the magnetohydrodynamic flow vortex structure. Okay, you also get charge separation of 3.6 trillion volts, which polarizes the vacuum and allows for the production of electron and positron pairs out of the vacuum. Well, when you have this structure, the phase singularity that you've just seen in this structure, especially if it's a resonant structure, allows for, according to the persons that wrote this paper in 1995, who were on the periphery of the Soviet energetics program, they say when you get a wheel within a wheel within a wheel within a wheel, you get one closed Poynting vector, which produces electromagnetic phantom, and another one at 90 degrees, orthogonal to it. But anyway, even one closed Poynting vector can cause vacuum sort of polarization and positron-electron pairs. When they annihilate, they will produce 2 photons of 511 keV, and they can be captured by the electromagnetic phantom. This means you can capture photons. So just showing this means that you can capture photons, not even just from a electron and positron annihilation that's caused by the vacuum polarization. So why is this important? Because we have a structure that has such an intense confined energy that it can start to pull in more energy and feed off the environment. Okay? And when you have trapped electromagnetic energy, That is the description of the Kugelblitz, the pure electromagnetic black ball lightning black hole. Okay? Now, as Tesla witnessed, and it inspired him, a snowball rolling down a mountain when he was in something like the Slovenian mountains rather. He saw this snowball rolling down a mountain. It got bigger and bigger and bigger. And he realized at that moment, if you kept putting energy or something into the same rough space, that it could build and build and build, and it would vanquish anything. So if you have a system where a single place in that system is able to accumulate energy, at some point, if it is not dissipated, it will produce energy fields that lead to the formation of a black hole. And there was this other paper that I talk about from R.P. Wisniewski, 2008, and he is saying that a Paul Dirac compliant monopole structure, which is a topological monopole, is formed from something that forces electrons to get into phase and come down to a magnetic core and be coherent. And so this is like the ring core of a Kerr-Newman black hole. In a Kerr-Newman black hole, you have a ring singularity. And this is essentially a ring singularity. The electrons can only orbit at a minimum orbital distance, but they are bosonic, and so they produce a topological monopole which has incredible magnetic fields. And when you have magnetic fields that are over 10 to the 15 Tesla, 10 to the 15 Tesla, that can start to pull and deplete the vacuum energy local to that black hole. And here is the really interesting thing. When you run the maths, the smaller the black hole is, the bigger the magnetic field. The smaller the magnetic field, the black hole is, the larger the ability for it to deplete the vacuum energy. And you only need to create a magnetic field of the order of 10 to the 15 Tesla. I've done the calculations. It can produce a field if you have a very, very small structure. I mean, really, really, very, really small. It can produce a magnetic field of over 10 to the 55 Tesla. Way, way more. Now, a normal black hole, the smaller it is, the faster it will evaporate via Hawking radiation. That is, vacuum fluctuations, polarization of the vacuum, positron, electron, one falls in, one doesn't, also photons and whatever. And so it depletes its energy in this way. S.V. Adamenko observed black hole-like objects consuming ions that he was firing at them and radiating out that energy in an exponential decay. He also saw around the central black hole several regularly spaced structures which did the same thing. He fired the primary ion from the secondary ion mass spectrometry in there, did not see any secondary ions, did not see the primary ion, only saw a glow on the phosphor screen that decayed exponentially. And so he had essentially made black holes surrounded by black holes. And I talk about this in my 2018 presentation that I gave in Sochi to the Russian community. So when you get that, and you get over this threshold, if you deplete the vacuum energy to a certain level, what do you think happens? What do you think happens? Have some guesses. Any guesses? Any guesses? Collapse? No. It goes pop? No. You get quartz? There's a good chance to guess. Right, okay. What you get is exactly what you have seen. Matter falling apart. Now, what did we see? We saw a film of carbon coming off. We can't see the oxygen. We can't see the oxygen because it's a gas. The carbon gets deposited when the system collapses. Why? Why do we get a film of carbon coming off? Why do we maybe get alpha particles, which is helium, coming off? Why do we potentially get oxygen? Okay, why does this happen? We know because if you recall in the, and I will go here, in our system here, we have seen that in this cavitation ultrasound system, we saw oxygen removed from the aluminium here because we had boron crystals and no calcium inside the vesica Pisces, inside the golden ratio line. Then it went through a wormhole, came out here on the inside. This is the yang side on the inside. And inside the golden ratio line, inside the vesica Pisces, you saw aluminium, some isotopes of calcium are aluminium plus oxygen. So we know from the decay on the tungsten that it can tear carbon out of tungsten. And from this one, it can tear oxygen. Why? I believe it's to do with binding energy and structure. Binding energy and structure. The first thing is binding energy. What is that? Well, that's kind of like the stability of a nucleon, a nuclei rather. There's no binding energy with hydrogen protium because there's only one nucleon, right? There's no binding energy. But every other element isotope has binding energy. And this is the amount of energy you would need to put in to split those nuclei up. Sorry, those nucleons up from the nuclei. Okay? So one of the hardest ones to split up is actually an alpha particle. It's really tightly bound. This is why you get so much energy from fusing, two deuterons to helium. You get a vast amount of energy per nucleon, which means if you want to split that helium up, it's really, really hard. Secondly, carbon and oxygen are made of carbon, triple alpha, and oxygen, quad alpha. Silicon is 28, so it's sept alpha. Sulfur is oct alpha. Calcium is dec alpha. So these alpha conjugate nuclei are really tightly bound together. Iron 56 overall is the highest binding energy of any nuclei. It's pretty much similar to nickel 62, but you have to put energy in order to reorganize the nucleons to get to nickel 62. So iron 56 is where the music seems to stop and where a lot of cosmological theories would suggest is the limit to normal star building. And you need to go to a thing like supernova. You don't. You don't, my friends, you don't. But then I'm just talking about binding energy. And typically binding energy is calculated per nucleon in the nuclei. What binding energy is missing is a discussion on structure. Now, I could have chosen the structured atomic model. It's quite a nice model. But what I'm going to show you now is Pavel Osmira's structured model of atoms. I like it because I would, because it's based on fractal toroidal geometry. of the underlying protons and neutrons. So bear with me, I'm going to pull that up. So I've shared this recently. Don't ask me why. This has gone to a weird shape. Okay. So this is his revitalized water paper. And he has this toroidal model of the proton and the electron. Absolutely everything is made of ether particles, of course. And so if you want an alpha particle here, you have 2 neutrons and 2 protons, and so forth. So the nuclei is not a ball of spheres. It's not a ball of spheres. It's a ball, not a ball at all. It's a structure here of substructures. Now, can you understand where I'm going to here? Can you understand what I'm about to say? Any idea? Toroidal clustering? No. In the context of how I led into this, what do you think I'm saying? Wheels and wheels and wheels? No. Think about how something would fall apart if we considered this model, and then think about how something would fall apart if we considered a structured model of the atom. Anyone get it? No. Okay. Everyone is thinking, because they think that the structure of the atom is like this, and it doesn't have any real structure. The nucleons just all reorganize themselves, right? That every single nucleon has the same binding energy, but it doesn't. Some nucleons, like a cluster here, has individually a different binding energy than this one, and this one, and this one, and this one. And then this one here might have a lower binding energy than this one here. So what is happening, my friends, is you are getting what's called cluster decay. And the reason is, as your vacuum pressure on this structured atom model is depleted, the first thing that goes at this level, at the subatomic level, is not all of the nucleons falling apart. It starts to break up based on the weaker binding energy of these parts of the structure rather than the individual cluster. So here's a periodic table. And so you can imagine that some parts of these structures would fall apart easier than others. Yeah? So let's say we started off with something very, very heavy, strontium here. Well, there's bits that are weakly bound on the outside, and they are likely to be light elements, so you could have a chunk coming off, and the chunk basically self-assembles into oxygen or carbon. So overexcitement by flux of chi being forced through without the ability of having a space-time density, of having a vacuum energy density to release that energy into, and removal of the chi for able to be allowed to emit the extra energy, over-energizes matter, condensed matter. Condensed matter is and does include liquids, solids, plasmas, gases. All of those things, not necessarily in that order, they are all what's considered condensed matter. Now, the nuclei gets over, and the overall atoms get overexcited by this flux of chi that's being pulled in by the toroidal moment, the vortex that's coming in. That excites it. It can't get rid of it because the clusters of relic neutrinos, which are the chi, are being pulled into the structure itself via their own toroidal moments. And so it has an inability to get rid of the energy that it's accumulating. Okay? That starts to make weak polar bonds or van der Waals bonds or metallic bonds, which are pretty weird anyway, start to fall apart. And then, covalent bonds are like the last in the line. But then it starts attacking the nuclei structure, the actual nuclei structure. And it is breaking it apart, in my opinion, based on clusters. Okay? So when we see in the work in the study and analysis of samples such as those on Henk Uren's system here, all right, on this one here, when we start to see all of these elements here, and if we go down in this one, there's a breakup here, and, oh, sorry, I'm not showing you, am I? Sorry. Here, we've got all these different elements here, and in this one, we have predominantly in the center, we have the iron and oxygen, then these chunks are silicon and oxygen, and then these are calcium and oxygen. And you can go look through the history of these various presentations on these various data. The interspersed material here is sulfur, it's chlorine, it's potassium, it's magnesium, and so forth. In my view, these were never caused by fusion or fission. They were caused by cluster decay through vacuum depressurization. So when you see in the emissions from Binwen Huang's reactor parts, when you see these fluxes of coherent matter spewing out, like here, in a sort of blended stellar synthesis sense. And in this case, the coherent matter has come out and immediately formed a crystal of a range of atoms. And in the case of the thunderstorm generator, we see a ball lightning at the end of calcium sulfate. Calcium sulfate is comprised of calcium decalpha, sulfur octalpha, and oxygen is quad alpha. It's comprised of a vast number of alpha conjugate nuclei in what I believe are very stable variations of alpha conjugate nuclei. Oxygen must be a key thing, and the reason is it's the highest by far element in the crust of the Earth. Silicon is the second highest, and that is a combination of carbon and oxygen fused together. It's sept alpha, it's 7 alpha particles. So there we have it. A lot of the transmutation is caused by depressurization of the vacuum, just as we saw depressurization in the hydrodynamic system, as I showed in the work of Suhas Ralkar. Depressurization. Matter is pulled into that through that vortex by overexciting the matter, so it becomes the bonds, all of the bonds, whether they're metal bonds or chemical bonds, they can't hold on to the other matter around them in the same sense. They become non-thermally fluidized. Okay, and then it basically sucks it up into the vortex, and it depressurizes it further. Why? Because the Kugelblitz, the electromagnetic black hole at the center, and also the kind of ring singularity that gets synthesized by the topological monopole, conspire and combine to depreciate the vacuum integrity in the local space-time. And if you can, from a very, very small structure, produce higher energies of this kind of vacuum destructuring, it makes complete and utter sense why a smaller subtor would survive longer than a tor at the end level above it, because this one will have at its core a smaller black hole. It can't accumulate as much matter. It doesn't have as a broader vacuum, but what it does have is a stronger magnetic field. So it maintains its structure longer. Ad infinitum down the fractal levels. Ad infinitum down the fractal levels. Okay? So now we're going to go further. We are going to go further than what I've just told you. We'll go back to the work of, where are we? If I've got it here, oh, did it collapse? Have I lost it? Okay, here. No, that's not it. What's happened here? Okay, why has it done that? Okay, I'm having an issue here, just bear with me. No. Okay, I'm going to go there. Here you can see in his models how well things are bound together. You have electrical repulsive forces in green and attractive magnetic forces in purple forming this structure. And we have 1, 2, 3 protons, 1, 2, 3 neutrons. Here you have another structure here. And you can see how you can imagine that the binding of these parts together are not necessarily as strong or differently strong to the binding of these parts together. Okay? And he goes on to talk about the binding and the orientation. And you see here, carbon, the parts of carbon are this end and this end of silicon. Okay? So if you were to depressurize silicon, you would form carbon. And what's in the middle? Well, if you're taking carbon off silicon, you would end up with oxygen. If you take carbon off silicon, you would end up with oxygen. This is making glass fall apart. 2 110-story buildings are not even a small fragment of glass. The event. Just leaving that hanging there. Vacuum pressure causes silicon in silicon dioxide in glass to become carbon and leaves oxygen behind. That means the oxygen goes into the atmosphere and the carbon is a single atom of carbon. A single atom of carbon has not got enough scale to settle. It will float away as dust in the wind. Again, there is a carbon part on germanium and there is an oxygen part, or rather there's 2 parts of carbon on germanium. There is the same structure here on tin that make up carbon. So when cluster decay happens on nuclei, often you are able to pull carbon off the ends of the structures in a vacuum decay situation. leaving a not fissioned, a cluster decay, but a cluster decay because of pressure changes. Okay, so I'm going to go to one of his other papers here in a minute. And my machine over here is struggling, so I'm going to have to remove some things that are running on it. Okay. Oh dear. Tedious. So tedious. Okay, maybe I'll have less problems here. I'm struggling. Okay. All right. Let me go and see if I can find another paper here. Are there any questions at this point? So why do you see so much carbon flowing out of that tungsten? It's likely because at the end of the tungsten structure, there are weakly bound parts that when they're pulled off, they immediately form carbon and they form oxygen. I think I know what's going on here. It's mirroring my screen. It's not actually... Okay, let me see if I can fix this. That's why my screen's all messy. And I have only one screen. Give me a second. This is tedious. Okay, this will be a little bit easier for me. Actually makes sense. Oh, I need to go to, you can go to Pavlo Smira's website. So we will do that. Why not? Let's do that. So we're going to go to Pavlo Smira's website. Here we are. This is my friend, Pavlo Smira. He lives just up the road from me in Brno. And we will go to publications. And we will go, let's have a look at ring structures of matter. Okay. Ring structures of matter. October the 18th to 20th, 2017, Brno, Czech Republic. Blah, 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 blah. Here is the same kind of thing that I was just showing you here. Okay, not that one. So, not that one. Ring structures of atoms and molecules. Okay, so here we go. When you go beyond your proton and neutron, you have gluons and quarks. Okay, so you have gluons here binding together your three quarks. Now, what is necessary in neutrons and protons is that you have three colors of your quarks: red, green, and blue. You must always have a red, green, and blue quark in order to add up to white. Okay, so both the neutron and proton has a red, green, and blue. Okay, and you can see that the difference in the twisted torus of the substructures here is you have two, let's call them open tori here, and a closed tori, and here you have two closed tori and one open tori. Okay, and this is how they're binding together, and he shows how that leads to the binding of your clusters. Okay, so I will show the maths, and I will show that within the Kugelblitz, the purely electromagnetic hole, and or the topological monopole, you can get to a point where the vacuum pressure is sufficiently low, depleted, and it just so happens to be, as I said earlier, actually this 10 to the 15 Tesla, where nucleons actually fall apart into quarks and gluons. And quarks are leptons. They have a variation of the toroidal moment, but they also have charge. And so they can be pulled into the core as well. And what happens is, this is really taking the inside out of an atom. And then it's taking the inside out of a nucleon. And what we're getting down to is a type of matter which was at the birth of the universe. It was at the birth of the universe. A quark-gluon plasma toroid. A quark-gluon plasma toroid. This is the real plasmoid that lives for 2 days in the work of Bogdanovich. And that, my friends, is a boom. This is a real boom. What I'm talking about here is desynthesis of matter, decaying of nucleons. Decaying of nucleons. And whilst your proton and your neutron take about 1 femtosecond for the speed of light, a light ray, to go across their diameter, a quark-gluon plasma is actually quite voluminous, and it can become coherent in the same way your electron plasmoid can become. And in fact, it is likely to form the same kind of magnetohydrodynamic structure. And my friends, you can form a magnetohydrodynamic structure out of a quark-gluon plasmatoid. It takes on the pattern of the electrodynamic structure that is produced, that I've been sharing with you all of these years. Now, the letter that I sent to the Sapphire group in 2019 or whenever, 21, whatever, it was nearly 4 years ago, 1 week from now, that I shared on remoteview.icu. I specifically referred them to Ken Shoulders, referring to the work of Adamenko as creating a quark soup. And that, my friends, is why you have a soup with the magnetohydrodynamic structure in the top. The soup is a quark soup, but more specifically, it's a quark-gluon plasma toroid magnetohydrodynamic structure, which, my friends, is also fractal. And when you do the maths, you can create a quark-gluon plasma toroid that has sufficient magnetic strength of 10 to the minus 15 to sustain this process if available electrons or baryonic matter is in its vicinity. Enough material constantly feeding into itself, because it will have the ability at less than 0.7 of 1 micron to have the required 10 to the 15 Tesla field. When you do the phase transition from ordinary matter to a quark-gluon plasma toroid, from a electron-based coherent plasma toroid, which includes ions of clustered decay metal and clustered decayed matter. In that core, originally, you will have predominantly cluster decays. Thank you, Ariane Lu, for that donation. Very generous of you. Matter in that core will include electrons, degenerate electrons, plasma, plasmoids. It will include nuclei and nucleons and degenerate electrons. But ultimately, it will lead to a magnetohydrodynamic structure that isn't based on those. It's based on a quark-gluon plasma toroid, a plasmoid. And at that point, it becomes self-sustaining. And according to the person that reached out to me after I shared the work of Bogdanovich on the long-lived plasmoids, he said that in free electron laser treatment of military landing gear, they had observed these glowing structures, which must be the same as Bogdanovich, that were surviving for months at a time. Now, when I asked the people at Sapphire 4 years ago, and specifically referenced to look at this concept, and specifically referenced the work of Adamenko, I'd only just skim-read some of Adamenko's work. But after I had worked out that this is what is going on, and I'd verified the maths is possible within the size of the structures that we witness, I thought I'd look at his book. And I was utterly blown away. So firstly, let's go to Wikipedia and just look at what Wikipedia has to say about quark-gluon plasma. Yeah, let's have a look at that. We can all look at that together. Why not? Quark-gluon plasma. Let's have a look at that now. Quark-gluon plasma. Okay, here we go. What do we got? Oh, there we go. Top thing is our friend Wikipedia. A quark-gluon plasma, quark QGP, let's go and zoom into this, is, or quark soup. Oh my God. Oh my God. That is exactly the phrase used by Ken Shoulders. When did Ken Shoulders use it? He used it in this paper called Primordial Substance, which was in 2011. EVOs are considered by the author to be composed of a myriad of electromagnetic wavelets instead of conventional particles such as electrons. A note on this viewpoint entitled Detecting Fundamental Wave Action in Elementary Particles by Using an EVO was placed on the web for download. At this point, further consideration of this complex array of wavelets introduces a strong possibility that the ensemble can also be characterized as a primordial substance capable of, under proper but relatively ordinary conditions, resolving itself through physical manipulation into all known elements and perhaps some yet unknown substances. As unlikely as this assertion presently seems, some supporting evidence will be submitted here permitting such conjecture. It is in the field of cold fusion where the greatest accumulation of anomalous transmutation evidence exists outside of direct EVO research, and that in spite of the presently ignominious stature of the field, has much to offer. The author finds that whenever transmutation is found using mass spectrometry and high-resolution microscopy on cold fusion samples, there is an accompanying set of EVO strike marks or tracks signifying EVO presence. These are usually examples of EVO striking materials such as metal, where excess charge can be dispelled. To see such examples interested, readers should refer to early papers by Ken Shoulders and put on the web for download here. In particular, the paper Energy Conversion from Exotic Vacuum Revised shows that all methods of cold fusion energy production and nuclear transmutation are linked to exotic vacuum objects. The necessity for EVO involvement with cold fusion strongly shows in some of these papers. Although direct excitation of EVOs by one striking another in the absence of nearby condensed matter is the ideal method of proving that an EVO is composed of something like primordial substance capable of directly generating matter, it is a more difficult method to execute due to the need for a 3D trap or container to carry out the transformation without contamination. Such a device capable of doing this has been built and tested for EVO containment, but at the time that work was done, no thought was given to tests of matter creation through EVO interaction. Those tests still lie ahead, and very sadly, he was to die just a couple of years later. He had not conducted these tests. In all tests with exotic vacuum objects reacting with condensed matter, a different isotopic ratio shows when compared to so-called natural ratios. This is to be expected due to the creation of new matter by an entirely different and much milder process. This EVO-based method should be called the natural state due to the absence of radioactive species and an abnormal and highly stressed state. Some years ago, cold fusion literature introduced the notion of nuclear active environment, or NAE. It is now appears to be this author that the site for the EVO becomes NAE as long as the EVO can then be excited to a redistribution state of primeval energy or primordial substance composing it. Another mysterious spot at which the nuclear reaction originates without an EVO being present to do its work is not needed. The EVO does the whole job of creating new and different material as well as heat production through the acceleration of normal particles with subsequent dissipation of energy in the lattice. I believe that EVOs are the mothers of all matter. Okay? And I will then find his quark soup quote. Okay, here we go. Quark. Okay, I can't find the quote here exactly where he referred to it as quark soup, but you'll have to trust me, it exists. And so what is a quark soup? Well, as I said here, it is a quark-gluon plasma. So Ken Shoulders specifically spelled out what it was. Is an interacting localized assembly of quarks and gluons at thermal, local kinetic, and close to chemical abundance equilibrium. The word plasma signals that free color charges are allowed in 1987, blah, blah, blah. Okay? And basically, a quark-gluon plasma is what the universe was before hadrons, that is, mesons, and baryonic matter were formed. Now, here is the incredible reality of what you can do when you have a quark-gluon plasma. If you slightly destabilize it from time to time and you cause a quark and an antiquark, because if you have vacuum decay of a nucleon, like a proton or a neutron, what happens is when you try and pull out a quark, the energy you put in to pull out the quark creates the antiquark, okay, of the same type. So what that quark and an antiquark pair are is a meson. And mesons decay, drum roll, into, you ready for it? Electrons, photons, and neutrinos. Boom! This means when you understand how to use this technology, you can convert bogies and shit into light and electricity. Forget the neutron. It's a relativistic neutron. Won't bother you. It goes away. We can convert any matter at all into electrons and photons. Electrons and photons. That includes rarefied matter like relic neutrinos, which you can capture from the cosmos. This means you have unlimited energy at any point in the universe which you can utilize. Anything. Anything is fuel. You can transmute matter effortlessly, just as we have witnessed in cavitation and plasma systems. Its cluster decay goes to quark-gluon plasma. When that quark-gluon plasma's confinement field fails, it re-enters our ordinary vacuum state, 10 to the power 112 joules per volume. In that vacuum pressure state, with all of the ordinary photon pressure, what happens? Instantaneous micrometric crystals in an open volume. The phrase that is used by Mikhail Solin in his 1992 paper, Quantum Coherent Nuclear Reactor, his patent, Quantum Coherent Nuclear Reactor. He says, when I use a free electron laser onto a refractory metal like tungsten, in the melt, in the resonant chamber of the melt of the refractory metal, you get magnetic charges of two kinds. They cluster and lead to a unification of the forces. That is what occurs inside the black hole. Inside this volume of this structure, matter loses all identity and becomes a quark soup, which is specifically a quark-gluon plasma. And in that state, it's basically a bunch of wavelets, which is in a coherent state. When the confinement field breaks down, the matter comes out. And depending on the rate of that breakdown or the substructures, you'll end up with new matter being born. That is the process of electronuclear collapse. That is the process. That's why out of one pole in this sphere of lead, you are having a lot of carbon spewing out. Now I thought, since I personally had said, based on the statement of Kenneth Radford Shoulders, that this was a quark soup, which is specifically a quark-gluon plasma, that is the basis for plasma toroids when they are at the level where they take on the pattern via creating the Kugelblitz, the magnetic topological monopole that changes the vacuum pressure sufficient to cause baryonic matter to fall apart, creating mesons and a quark-gluon soup that takes on the magnetohydrodynamic structure and is more effective at creating the magnetohydrodynamics necessary to produce that 10 to the 15 Tesla and higher, necessary to perpetuate the process and self-sustain the destruction of matter. The destruction of matter as observed in cavitation by Kladoff in water systems. And the synthesis of many elements. And the longer you run it, the heavier the elements get. I thought I would have a look a few days ago at the book that I have from S.V. Adamenko. And I would look for these things in the book. And I'm just going to pull out a few things here. But the book that I'm referring to, I need to go to my play books. Maybe I've got it somewhere looked up here. File. File, new tab. Can you understand why I was so scared about the implications of what I was seeing in 2019? We already knew what it could do, but I was seeing under the microscope the exact way it was doing it. It was depressurizing the matter and it was causing cluster decay. It's literally falling apart effortlessly. It was a huge ontological shock. And hopefully some of you guys can understand it. You can internalize it. Remind me what I'm looking for. I'm quite tired. What am I looking for? What was I talking about? Oh, yes. Play Store. Have I got it in another window? Don't know. Oh, well. I have to load it up. I'll have to load it up. Oh, no, I've got it here. Yeah, there we go. Right. So I've typed in the word quark. So what we are looking at here is, I'll get rid of the word quark and we'll search again. So this book is about $160 in a form of a online book. It's called Controlled Nuclear Synthesis. Oh dear, what did I do there? I didn't want to do that. Okay. Okay, Controlled Nuclear Synthesis, and it was published in 2007. And you can see here, and I mentioned this before, Brian D. Josephson. Yes, that is the same Brian D. Josephson of the Josephson Junction. And also in a previous video, I talked about some of these characters here and how they are very, very significant characters in research around the world. Lawrence Horowitz from Tel Aviv University and so on. But yeah, Brian D. Josephson here. Okay. All right. Now, this is called, as I said, Controlled Nuclear Synthesis. Breakthroughs in Experiment and Theory. And it has 754 pages. Okay. Right. I typed in the word quark and there are 13 results. So we'll go to the first one down here and we will zoom in and see what it says. The idea consists in that the action of very strong magnetic field whose intensity is unknown, but is presumably attainable under laboratory conditions. Where is that? What happened there? Okay, I lost it again. Oh, what happened there? Okay. It's kind of off page. Why is that off page? That's not very helpful. Okay. Okay, so I can't, I'm trying to zoom into this without losing the text. And when I go like that, it loses the text. Okay, so hopefully you can see that. The idea consists in that the action of a very strong magnetic field whose intensity is unknown but is presumably attainable under laboratory conditions induces the dissociation of colorless aggregates of quarks, hadrons. Hadrons are basically mesons and stuff, at which the super strong, not decreasing with increase in the distance according to the chromodynamics, interaction is realized as the repulsion of quarks whose spins and magnetic moments are oriented with the violation of ordinary rules valid. Anyway, he's saying basically you need some magic magnetic field that allows for the this decay process to go on. We'll have a look here. What does he say here? That's more of the same. Okay, all right, there we go. All right, okay. This effect can be named as the color disconfinement in a strong magnetic field. So disconfinement of quarks by color disconfinement because of a strong magnetic field. The process of scattering is running through a bound virtual compound nucleus in the form of a cloud of nuclear matter, a quark-gluon electron plasmoid. A quark-gluon electron plasmoid. So he's throwing electrons in there as well. We know we've got electrons in there. We started with those, right? So matter becomes an overall quark-gluon electron plasmoid, which has the density much less than that of nuclear one and is spatially expanded over the interatomic distance. After switching off the magnetic field, this cloud returns to the state of ordinary, strongly bound hadrons, mesons, and baryons with steadily ordered spins and magnetic moments. The composition of nuclei in the final state can differ from the initial one. This literally sounds like Ken Shoulder's paper that I showed you. In this case, the creation of protons and deuterons is more preferable as compared to alpha particles, since the appearance of even nuclei with zero magnetic moment is obviously improbable in a super strong magnetic field. The above presented assumption about the possibility of super strong magnetic field to influence the internuclear process can be valid for weak nuclear interactions, defining the stability of nuclei relative to the beta decays. At present, we consider the defining influence of the electron system of atoms on the natural beta stability of nuclei as the established fact, which is the equivalent to the account of effects of the collective electromagnetic field of electrons shells on the nucleus of the center of the atom. Because the beta activity redistributes nuclei in the limits of isobaric Fermis, we cannot explain the appearance of new light or heavy nuclei by the action of super strong magnetic field on the weak interaction of nucleons, but can understand why collective magnetonuclear catalysis leads to the observed effect of the beta stable composition of synthesized nuclei. So basically saying whatever goes on ends up with stable nuclei. That, my friends, is radiation remediation. Radiation remediation. So what else have we got here? What is it? He's got that there. Okay, so he says the dynamics of the process inside this region is very complicated and requires additional comprehensive study with regard to the processes of creation and annihilation of particles and running all kinds of nuclear transformations, including possibly those with the creation of quark-gluon plasma. There we go. The second level of baryon substance, quark-gluon related degrees of freedom, the quark-gluon plasma is formed. Okay, so they have the mathematics here for the formation of quark-gluon plasma. Okay, right. Okay, this is freaking amazing. It blew my mind. Essentially, you have a chart here. And what we know is in our system, matter is falling apart in cluster decay. If you've got ions, whole nuclei are coming in. So you've got nuclei, you've got cluster decay nucleons, then you have quarks and gluons and electrons, all in this soup in various parts of the structure. And what they're saying, in various densities of the degenerate electrons and so forth, you can have neutrons, quarks, and so on. You end up by increasing the density of matter. And it says over a long range, up to a certain log n density of nucleons, you do not produce anything other than iron 56. But at a certain critical threshold of density of matter that you put into your structure, you start to create heavier nucleons. And so up here, you start to get things like gold, you start to get things like uranium, you start to get things that exotic atoms, and you get things that they produced, which are up to 700 nucleons that are not normally in our near universe. Boom! What have I just said there? I've said that using this system and baking it for just the right amount of time, you're going to get well beyond iron. And I know what you're all thinking. I know what you're all thinking, you naughty little people, you. You're all thinking, my precious. Yes, my precious. Mostly you're going to get iron, the most common found thing in cold nuclear transmutation. But we have synthesized, it would appear, in the Binge-Wenhuang reactors, it would appear you're getting silver. But maybe that's coming from the solder. But we did get silver forming in a twisted, braided thing coming out of the side of a yin-yang cone in an ultra experiment. We did see a twisted toroidal structure in an electric discharge on a nickel plate in a nickel sulfur solution in Suhas Ralkar's electroplating system in 2017. We got silver. Now, what is silver often found with? Well, the single nugget that made the wedding ring here for me and my wife. I bought from Alaska, and it was, I think, 92.5% gold, and the rest was silver. Silver is found alongside gold often. I believe it's synthesized alongside gold. We are going to enter an era of abundance. All of those precious, precious minerals, those precious elements where we chew up mountainsides and destroy landscapes. No, you can just make them. And you can make them the same way the earth made them, working with nature. You just have to have resonance. And what's really good to do resonance is sound and vibration in phase conjugation modes. That is what will lead you to be able to energize a particular part of the structure. Just as you saw on my slide presented on the practical applications of the fractal toroidal moment in Poland, in ICCF 25 in Szczecin. And here it is. I will find it for you now. It's in the background, and I've discussed it since, but I put it in the background of a slide for people to see, and I've discussed it since. Okay. This was the end of a sample that I asked George Hathaway to give me to analyze. And in the scallop sections from the aluminium, we see iron in the center. Iron being the fusing of two aluminium nuclei. And then in the overall center of this overall structure, we see a sphere which is largely copper. Largely copper. Copper is beyond iron. So John Hutchison, it would appear, was able to synthesize elements beyond iron in this particular example. But I imagine that if you got the right frequency, not just using sound in water, which we know has synthesized things, with the right pulse or whatever, you are going to have systems that can produce elements. And what happened in S.V. Adamenko's work, they shot a 300 joule into, say, a copper slug, a little billet, little pin, and in the accretion disk, they found some spots that were 83% gold. And that is from a shock. There's two ways you can do this, a shock and a resonance. A shock and a resonance. With a resonance, I believe you can be much more controlled. You can build and build and build, and this is where statistics comes in. This is where statistics comes in. So I'm just going to have a look at what was the other data points here. Like I say, I've done all the maths, I've verified it, it works. We can know that this works. So I'm just going to read some things that I pulled out of Adamenko's book, which is called Controlled Nuclear Synthesis. On page 29, he said, the most important property of the gravitational collapse, which is the same kind of thing and same kind of language as this, which came out before the work of S.V. Adamenko. In fact, this was published before S.V. Adamenko started his work at Proton 21 in Kiev. The most important property of the gravitational collapse is being initiated by a self-generated common dominating disturbance, which has the character of a mass force and emerges due to the coherent amplification of gravitation effects for a macroscopic ensemble of particles of matter located at the same distance from the center of mass of the collapsing object, those located in the volume of a thin spherical layer. Collective self-consistent coherently accelerated motion of set of particles of matter where the centripetal component of the momentum of each particle is much higher than its thermal chaotic component brings a portion of the matter made of those particles into special collectivized critical state. From page 30, he says, in the state with strong correlations, the optimal conditions may emerge for the avalanche-like spontaneous creation of highly organized, multi-particle, multi-linked, dynamical network structures. Wonder what they could be. In thin macroscopic structure, spherical shells with a common center of mass, the dynamical structures may emerge on the basis of all kinds of physical interactions, including the strong and Coulomb ones, for which the necessary conditions exist within the respective shell where the matter is in the critical state. Those processes should probably depend on the reaching of a threshold densities by the matter within the shell in the state of the electron, nucleon, nucleus, plasma. Electron, nucleon, nucleus, plasma. And you know the thing that's easiest to be just a nucleon, which is also a nuclei? Its atomic proteome, i.e. the simplest nucleon, which is nuclei, which is a proton, which is the core of atomic hydrogen. Now, do you understand why atomic hydrogen is so good to feed this machine? Because you don't have to break it up for like a bigger atom before it can go into the core and start feeding the process. This is why I believe when we add hydrogen to the Vega experiment, suddenly it starts performing the coherent structures. And of course, you've got hydrogen that's immediately accessible. And I've showed this in Ultra experiment where we showed that the aluminium plays a role creating aluminium oxide, and that grabs the oxygen from the water, leaving atomic hydrogen immediately in the place where the toroidal moments are forming. So water is the perfect combination with aluminium. From page 42, spontaneous creation of ramified structure of a macroscopic electron nucleon nucleus megacluster in the collapsing wave shell, active processes of detonative nuclear combustion of matter in the collapsing wave, several self-sustaining increase in the number of particles as well as in the integral and specific energy of collapsing macroscopic cluster. Wow, that's a word salad there. Page 408, in particular, the presence of the degenerative gas of relativistic electrons in the nucleus volume decreases sharply the Coulomb repulsion of protons. In the framework of this quasi-neutral model, the arguments about the hydrodynamic instability of nuclei lose their sense. In addition, with the model, the interaction of electrons and nucleons leads to the self-similar self-compression of an electron-nucleon system up to the state of Coulombic collapse, and finally to a sharp shift of the maximum of the binding energy from the ordinary A is optical at 60 to a very high value of A is much greater than 60 and even up to 3000. We believe that just this approach is valid for the system of many nuclei surrounded by the electron gas, where the Coulomb repulsion of nuclei is strongly suppressed, and the process of collapse can be realized under a certain external action. This model was intensively discussed in the previous section. Okay. So, in summary, what I've shared with you today is something that's been a bit of a torment for me since seeing the image from the Anomalous gas, which has atomic hydrogen in it, in 2019. I didn't know how to say this, and I was just as shocked to see that it's in this book by S.V. Adamenko from 2007. It is in line with the observations of Takaaki Matsumoto, and it is in line with the work of Ken Shoulders here. Yes, there's neutrinos involved. There's clusters of relic neutrinos. And so it's in line with the work of Alexander Parkhomov. collectively, with these various characters and what we've physically been able to share over these past years, shows that predominantly a lot of the synthesized matter that comes from so-called cold fusion is just etheric vortex cluster decay of matter caused by a electron-based initial plasma toroid plasmoid, and that leads to vacuum decay by way of a magnetic field that's around about 10 to the 15 Tesla, and that then the vacuum decayed baryons form mesons and quark-gluon electron soup. That itself takes on the structure of the magnetohydrodynamic structure, which caused its production, and that then leads to an intense, stable structure, which is a new phase of matter, which is stable in our universe. You do not need any other dimensions. This technology is a technology that gives you propulsion. It's a technology that can do lots of kinds of magic. It's going to end, in my view, a scarcity of energy, a scarcity of fundamental and critical technical elements. It has already been used, in my view, in terrible weapons. But I had to make a decision in 2017 whether I was to talk about what is going on, such that people could understand and we could all gain the benefit from this technology rather than just the weaponization. It's taken a long time, as you are aware, to work through the physical evidence and to understand the self-organizing structure that could do this, which is compliant with, in my view, anything that you're going to see in the future and anything anyone's going to reveal from secret programs that are hitherto undisclosed. It's going to be this structure. It's going to be a mechanism that's very similar to what I've just described, that allows you to do all the frickin' magic, all of the magic, all of the alchemy, all of it. It allows unimaginable amounts of energy from vanishingly small amounts of matter. The magnetic fields totally explain a 2 by 2 by 7 inch iron bar collapsing in on itself. Totally explain. The magnetic fields explain how ordinary matter becomes so dense. I believe that is exactly what they were doing with that classified process using an electron laser, a free electron laser, to harden military landing gear. They were causing a magnetohydrodynamic structure that then compressed that matter and made it harder. It's going to be interesting to see what happens now. Before all of the atoms that were in your body, if you were to believe the Big Bang Theory, were formed, they all had this prior state of a quark-gluon plasma. A quark soup, as it's called. This is every single thing that I've said in this video outside of the sacred geometry, which is the sacred geometry of Yore, which is fractal, and it is the same as hydrodynamics and magnetohydrodynamics. So like, if you're worried about using the word sacred, just say magnetohydrodynamics. But it is the sacred geometry, right? you don't necessarily need to know how this works to be able to use it. It's very likely that magicians of times gone by in the past could have understood a process by which, if they followed a particular spell, they could create an element, or a spell, they could teleport something, or a spell, and they could do X, Y, and Z. But it was this that was doing it. It's just science, but it is working at the root level axis of how the universe works. Creation and decreation, materialization and dematerialization. It is an immense, immense responsibility. Be interesting to see if this video is taken down. I don't know. I would suggest you copy it. It has been a deep, deep honor to do this work. Like I say, a more organized presentation will be part of my poster presentation. I would have liked to have given this as a talk, but it's just impossible in the time frame. You can't do this in 20 minutes. You can't do this in 20 minutes. So I'm kind of glad I got a poster presentation. And like I said, what I gave earlier today, which has a little bit more meat on the bones of how I got to this level of understanding, I shared this afternoon with a group. And actually, many of the groups had never been exposed to the work that the project has done and I've done myself. So I'm going to answer any questions now, if you have any. Hi, Joe Vellecci. Thank you for, I saw some comments that you had made recently, so thank you for your advocacy. It's interesting that other people are talking about tornadoes now and their importance. This is very good. Yeah, and you can transmute things in a microwave. I don't know whether it's very practical. I think if you made the Philosopher's Stone, these condensed relic neutrino condensates bound to what I believe is calcium-43 carbon 13 and 3 oxygen 17 predominantly, you could then use that material to do proper alchemy, and it would be very effective because you would have loads of the machines to do the work. So JK Filifan says, do you think the 3 times Beltrami effects? Well, yes, it's kind of a Beltrami vortex, to use that word. The same, similar to MHD mechanics. It kind of is. Yes. Zalapino says, how long before people start to see real change in their lives based on this technology? I think that's down to us. You guys are at the vanguard. You literally have the power now. You know, or you should know, that the fact that I was able to work this out from looking at things under a microscope and being able to cope with the trauma, and then you know, see it across so many different systems, was an honor, but also it was painful, because it showed me 100% certainly how this had been weaponized. It's one thing to know it's been weaponized, but to know how it was weaponized is a different thing. It kind of removes all doubt. And so, yeah, I think probably the most shocking thing I ever saw in this journey was that structure on that tungsten welding rod. And it's exactly the same pattern you see in the depressurization pattern in the hydrodynamic vortex in the water. Brandon B says, Bob, how do control what is transmuted? Can we pick the elements? I believe that a particular thermal phonon vibration in resonant cavities or particular sound will promote the formation if it's done for the correct amount of time. So a thermal, that is a temperature at a very specific temperature in a chamber that will allow for resonance, will promote the formation of a higher abundance of one or other elements. You're always going to get a mix. You're always going to get a mix, okay? So it's about, and I think the resonant process is the best. You will bake it. So how do we know that this is certainly the case? Well, I will bring up, have I got it ready here? I don't know whether I've got it ready here, but I'll just talk to the air about it. No, not really, but maybe maybe I can find it. Okay. So Kladoff, I'll just talk to it. If you go and look at the work of Kladoff, he showed that in his cavitation destruction of matter, that in his cavitation systems, he started off with a few elements, and if he ran the cavitation for a period of time, he got more elements. If he ran the cavitation for longer, he got more elements, and he'd keep it going, and so on. You get heavier and heavier elements. In the work of Leclerc, he actually produced transuranics. You don't really want to go that far, because those elements will decay with normal neutrons and normal gamma rays. And so you kind of have to bake your system with the right fuels, and it can just be cavitation for the right period of time with the right promoting substructures. So, for instance, we already know the scale at which the yin-yangs form on 43 kilohertz. We also know that if we use different frequencies, they will have different standing wave resonant nodes. So you will know what kind of structures you'll need to use to provide the spatial arrangement and the fuel in order to package up and make heavier elements. I can show you like silver and copper, but it's the silver slug that comes out of the side of a piece of aluminium that is so significant, because it's high ratio silver, and it blends into a carbon and silicon or something. So it's kind of like dyed, and it's got stock halfway through coming through the aluminium sheet. And what that showed me was that was coherent matter inside one of these structures that had reached the nucleon density to get up to silver. And that if only you keep that going, you'll slide up that profile line and you'll end up at whatever other element you want. So it's about resonance, and baking is probably more reliable than the shock approach that SV Adamenko used. Okay, I'll see what else you got there. That just means it can be weaponized against those people. It can always be weaponized. Tungsten gives off radiation, TIG welding it. Yes, well, if you come to, and I strongly encourage you to come to the Alchemy of Prague this year in September, we will be doing it. We're going to be getting, Jan Rack is already received, and we'll speak about this on the monthly meeting of the Evo Labs DAO. He's going to be buying the MFMP SEM with EDS. He's already very close to finalizing this incredible controllable and monitorable power system to drive a Henk-Urian Vega experiment. And he's received the first reactor body. And so they're very close to starting replicating the Vega experiment. What I will do at the practical day is we will take sections of welding rods and pure copper sheets. We will put those under the SEM. You might even be able to operate the SEM, observe that there's nothing more than a bit of oxygen, a bit of carbon, and almost entirely tungsten, whatever the low work function additive to that metal is, something like cerium or whatever. And then the copper is basically pure copper with a little bit of oxygen or whatever. And then we'll put it into the so-called dragon discharge and hold the copper plate, and you'll have the discharges going off and hitting the copper plate. And we will see, in my view, calcium formed on the tungsten and calcium as part of the marks where the exotic vacuum objects, the clusters, hit on the copper. And then you will be able to see that put in the SEM and see the transmutation. What I'm suggesting here is we are going to be able to categorically and repeatedly show transmutation live at will and guaranteed. Okay? We can do some cavitation experiments as well. And I don't know, it might be quite fun to see who synthesizes the heaviest element in the cavitation reactor during the day. That would be fun. And I'm sure that you could end up with protocols where you start off with maybe a whole bunch of copper sheet or a whole bunch of, silver or a whole bunch of, the problem with starting with something like silver or copper is that you might end up with something that's predominantly something of less value than the metal you started with. But let's say you could start with aluminium and you ended up with a lot of material that was more valuable than aluminium, then your quid's in, right? You always want to stop it too soon. You don't want to stop it too late because you'll start to make nasty stuff. We'll also show, because the ether vortex system, and I'll probably share these videos in the early part of the week, the ether vortex detection system that I shared from the Russian conference last week was built after a couple of days by my friend and colleague Paul Harris, who will also be at the both of them are coming to Cold Fusion Conference, but also they're going to be at the Alchemy of Prague. He has shown that it produces good detection of etheric vortices produced by the Griffin-Brock desmatron and also from the Therify. So I would like to get one of these to Binjuan Huang, and this means we potentially have a highly effective detector where we might be able to detect the toroidal moments coming off this. And it means I don't really need to get Brian Josephson to tell us how to make a Josephson junction at an affordable rate. We might be able to use this, and we might be able to use this in cavitation systems to know when we've got the resonance systems up to a level where it'll start producing certain elements. And basically, we literally have a whole blue ocean of opportunity here. It's just immense. It's mind-boggling to consider the opportunities that are here. It's a new industrial revolution. It's full-on manipulation of space-time, essentially. Okay, I have to go to the garage in the morning, so if there's no specific questions, I'll see if I can see anything. Yeah, I'd like to hang out with Praveen Mohan again. He's a lovely chap. I will do that at Cosmic Summit. So Cote Creative Studio said, what is that abbreviation for the device? Very interesting, Bob. Thank you. I'm not sure what you're referring to. What are we talking about there? Maybe you can ask the question in a different way. Marius Schmidt, my problem was getting consent to store hydrogen. You can get around that by using an electrolyzer. You can get them for about $600 or $700. We have one in Santa Cruz, and you can actually buy deuterium oxide, and you can end up by creating deuterium gas, or you can put hydrogen in there, or you can light water and produce protium gas, or you can mix the two and create ratios of deuterium to hydrogen for experiments. And then you don't have to have a problem with sourcing hydrogen gas. Nathaniel Hanks has asked about a blade. Yes. Yeah. Yeah, maybe I'll do that another day. A blade will be part of my conversation at Cosmic Summit. Yeah. Joseph Collins says, thank you, Bob. As always, amazing. Is there a link for the Alchemy of Prague? I will send out the link in my first couple of days of next week. You'll see some promotional material, download a brochure, and you'll see some photos and videos that we took on Friday in Jan Rack's lab. It's going to be fantastic, really, actually, to be able to do experiments. And it's quite fun because we have a day doing normal alchemy in the building where John Dee and I can't remember the other guy's name developed modern alchemy in the Western world. And you can actually, it's actual chemistry kits there. And we're going to be going and on a mushroom forage, and we're going to be distilling essences from mushrooms. And we're going to go into the Czech forest, and it's one of my passions. I've been wanting to do it for many years. It's going to be late September, so there is a possibility that there will be hopefully some good shrooms. So yeah. Okay, so this was O-Day Inside Out, where I believe that we have got to the end point which is necessary to explain all of the observed phenomena that is seen in the data that I have shared with you from physical analysis of real and independent and multiply replicatable experiments over many years, and in some cases decades. The complete destruction of matter, the potentiality to convert matter directly into electrons and photons, and the bulk cluster decay of matter into elements that are either directly that required for life, or then refused and emerge out as a spread of elements that are very good for life. This is the ability to terraform, to make suitable element mixes to support life on locations that may not otherwise do it. With understanding this and getting unlimited energy, making more oxygen or making less carbon dioxide or making more carbon dioxide or making hydrocarbons if you need them for plastics or pharmaceuticals, making elements that are rare. All these things are on the table. It's just, do you have the will and the conviction to go out there and make these opportunities for yourself, knowing with a certain level of confidence that it's possible? The hurdle has been breached. The lack of knowing that it's possible has ended, or thinking that it's impossible, that is finished. And you have the ability to take raw energy from the cosmos and manifest matter. and vice versa, take matter and convert that to energy. It is the matter to energy and energy to matter transducer. This was Inside Out. My name is Bob Greenyer. Thank you very much for your time. I'll speak to you in the next video. Buenas noches, dobranoc. Good night.